Hello friends, and welcome to the lecture number 4 on the basic course of engineering circuit analysis. Today we will continue our discussion on voltage. So we have already seen this circuit in the previous video. You are having your multimeter here, and it's your circuit element 1, and you are having two terminals A and B. So I'll connect the positive terminal of the multimeter to A, and then I will connect the negative terminal of the multimeter to B. And I told you, when I do like this, when a positive is connected to A, I'll put a positive sign here. Negative is connected to B, I'll put a negative sign here. And the measured voltage by this multimeter, say that voltage is V1, I will call it as V1. So let's go into a little bit more depth on this representation here. So the multimeter positive is connected to A, right? The multimeter negative is connected to B. What does this mean actually? What are you trying to measure? Actually, what we are trying to measure here is that we are measuring, follow closely now, we are actually measuring the voltage of terminal A, voltage of the terminal A, voltage of the terminal A with respect to the terminal B. This concept is very important in engineering circuit analysis and we'll be spending considerable amount of time. Also, we call this voltage, whatever voltage we are measuring here, that is the value of V1, we also have a notation for that. We call it VAB. Okay, this type of notation is called the double script notation. Double script notation. Alright. Now, what is the meaning of measuring the voltage of terminal A with respect to B? Basically, in simple English, it just means how high or how low the voltage at terminal A is with respect to voltage at terminal B, right? How high or how low the voltage of terminal A is with respect to terminal B. That is higher by 10 volt, higher by 5 volt, or is it less by 5 volt, is it less by 10 volt? The voltage you are trying to measure by connecting the positive of multimeter to terminal A and the negative of the multimeter to terminal B is basically how high or how low the voltage of terminal A is with respect to terminal B. The technical term for this is actually potential difference between terminal A and terminal B. Okay, so three things we have seen here. Now this expression VAB, clearly it is actually the difference of potential between A and difference of potential between terminal B. So a way of writing it is VA minus VB. But however, this is not the accurate way of putting it. We have to write something like this: VA0 minus VB0. What is VA0 and what is VB0? I'll just define now. So basically, VA0 is the voltage of the terminal A, with respect to a reference potential. Usually our reference potential is ground potential or 0 volt. Okay, and what is VB0? VB0 is the voltage of terminal B with respect to a reference potential, which is usually our ground potential, or 0 volt. Okay, so VA0 is the voltage of terminal A with respect to 0 volt, and VB0 is the voltage of terminal B with respect to a reference potential. We are taking our reference potential usually as ground potential or 0 volt. Now this expression that I have written here, that is VAB is equal to VA0 minus VB0, is very important, and therefore I want to do a small experiment to verify this fact. Okay, so we will be measuring VAB, we will be measuring VA0, and we will be measuring VB0, and we will see if this expression is correct. So basically what we are going to do in the experiment, we are going to measure VAB, VA0 and VB0. Okay, and then we will confirm if VAB is equal to VA0 minus VB0. And this experiment we will be doing with the help of this particular circuit here. Okay, so here I have taken circuit element number 1. So this is our circuit element 1. Okay, this is our circuit element 1. We will be measuring three voltages here. I told you, first we will be measuring VAB, right? We will be measuring VAB. Okay, so when I tell VAB, it means that A is measured with respect to B. Okay, therefore the multimeter positive will be connected to the A terminal and the multimeter negative, which is used to measure the voltage, will be connected to the B terminal. Okay, so this is the multimeter VM, which is going to measure the voltage between terminal A and terminal B, right? So I'll just connect it. So A has to be connected to the positive voltage. So positive is connected to A, and B has to be connected to the negative side. Okay, B has to be connected to the negative side. Okay, so this circuit is over. And now we will try to measure VA0. That is VA. We want to measure this potential VA, voltage across the terminal A, with respect to a ground potential. So for that, first we have to establish a ground potential. We will see in the future lectures how do we do that. But for the time being, just understand this will be our ground potential. This point here is going to be our ground potential. Therefore, we are going to measure the voltage between A terminal and this 0 volt. So for that, I have used another voltmeter, which is V1. So V1 is going to measure VA0. Okay, so as per double script notation, I am measuring the voltage of A with respect to 0 volt. Okay, so what will be the multimeter connection? A will be connected to positive, right, and 0 will be connected to the negative. A will be connected to positive and 0 will be connected to negative. So let us do that connection here now. So this is A, okay, and I am going to connect it to positive terminal. So let me connect it to the positive terminal like this, okay, and 0 I have to connect to the negative terminal, and let me connect it to the negative terminal. Okay, so that's also. So with this, you are going to measure VA0. And finally, we have to measure the voltage VB0. We have calculated VAB, VA0, and finally we have to find VB0. So we are going to try to measure VB0, and we will use the voltmeter 2 to find the value of VB0. VB0 means B is going to be measured with respect to 0 volt. So the multimeter connection will be B is going to be connected to positive and 0 will be connected to negative. Okay, so the positive terminal of V2 I am going to connect it to B, okay, and the negative terminal of the voltmeter I am going to connect it to 0 volt. Okay, so this will give me this voltage VM will give me VAB, V1 will give me VA0, and V2 will finally give me B0. So let us use a simple software to understand, and let us measure these values, and we'll come back. So already wired the circuit up for you. So this voltmeter which you see here, it is VM. It is going to measure the voltage between A and B. So positive of the voltmeter, you can see positive of VM is connected to the A terminal and negative of VM is connected to B terminal. V1 is going to measure the voltage between A and the 0 volt. A and 0 volt. So you can see the connection. Positive is connected to A. You can clearly see positive is connected to A. And you can see negative is connected to 0 volt. Okay, fine. This is going to be our 0 volt because everything is connected to the 0 volt here. Okay, even if you don't understand the circuit properly, you have to just see this value of the voltmeters. Okay, and V2, you can see V2 is used to find the voltage between B and 0 volt. So you can see positive I have connected to B, and the negative I have connected to the ground point here. And finally, all the ground points are meeting at this point. Okay, so we'll start the simulation and we will just record our values. Okay, so let me start the simulation. So you can see VM value, that is VAB, I have got it to be 5 volt, and VA0, which is V1, VA0 I have got as 10 volt, and VB0 I have got it as 5 volt. Okay, so we'll record these results in our notebook and let us see what conclusion we can get. So from the experiment that we just did, you saw that VAB, which is equal to the voltmeter VM value, was equal to 5 volt. VA0, which was measured by V1, is equal to 10 volt plus 10 volt. And finally, VB0, the value of VB0, which was measured by V2, was equal to plus 5 volt. Okay, so you know that. Let us find VA0 minus VB0. What are we trying to do? We are going to try to validate this relation. So VA0 minus VB0 is equal to 10 minus 5 volt, which is equal to 5 volt. Clearly you can see VA0 minus VB0 is equal to VAB. So we have proved that VAB is nothing but VA0 minus VB0. And this is a very important result, and I wanted you to feel this result. That is why we have done this experiment. Now let us just make some conclusions from this particular experiment. So you have measured VAB to be equal to plus 5 volt. This is what the measurement that gave. That means VAB is positive. VAB value is positive. But you also know VAB is nothing but VA0 minus VB0. So if VAB is positive, VA0 minus VB0 also will be positive. Okay, that means clearly if VA0 minus VB0 has to be positive, VA0 will be greater than VB0. And this we have already seen in the experiment, because VA0 was plus 10 volt, which is greater than VB0, which was equal to plus 5 volt. Okay, so this is one of the conclusions that we have seen. An important thing that you have to understand while understanding all these concepts is that, see, even if I did not connect this multimeter here, because of this circuit behavior, there would be a polarity which is existing here. And it is that polarity and magnitude that you are trying to measure with the voltmeter. See, the voltmeter is not creating the plus 5 volt here, right? The voltmeter is not creating the plus 5 volt. The circuit is creating the voltage and a particular polarity. You are only trying to measure that value using the voltmeter. So irrespective of this voltmeter being here, there will be always a voltage in which VA0 would be greater than VB0, right? This is existing as part of the circuit. And this VA0 minus VB0, the difference between the potential of the A terminal and the B terminal will be always plus 5 volt, because that is the circuit behavior. So what is the meaning of VAB is equal to plus 5 volt? It clearly means, for example, you are having this circuit element like this. You are having the circuit element 1 here like this, okay? And this is A and this is B. And by the circuit behavior, there already exists a polarity like this. There exists a polarity like this, which you are going to measure with the multimeter, okay? And what did you do? You connected the multimeter with the positive terminal to A, and the negative terminal to B, and you got the same value 5 volt. VAB is equal to 5 volt you have measured. What it means is that VAB positive means, irrespective of the value, VAB positive means our assumption. Why did you connect A to positive? You're just assuming that A would be positive with respect to B, or A would be at a higher potential as compared to B, right? That is why you have connected your multimeter positive terminal to the A terminal. VAB is positive means our assumption that A is positive with respect to B is true. There might be a case when you are doing a connection like this, and you might get a negative value. You might get a VAB is equal to a negative value. What does that mean? It means our assumption that A was positive with respect to B is wrong, and actually B is positive with respect to A. This topic we will see in our next video, which is part 3 of the voltage series. Thank you.